Welcome back. Today we're diving into something I'm really excited about, Alibaba's brand new Qwen 3.5 models. It's only been about 6 or 7 months since the last version, and they're already back with 4 new contenders. So today we're going to put 2 of them through their paces, right here on a local machine, to see what's really possible. Let's get right into it. So we're going to frame this as a classic head-to-head showdown. Think of it like a title fight. In one corner, we've got the dense model. This is your heavyweight, your brute force brawler. And in the other corner, we have the sparse mixture of experts model. This is the agile, hyper-efficient specialist. 2 totally different approaches are about to clash, but only one can be the local AI champ. Okay, so here's a full lineup from Alibaba. You've got a couple of massive cloud-only models, which are super cool, but the 2 we're really interested in for our local battle are right here. The 27 billion parameter dense model and the 35 billion parameter mixture of experts model. These are the 2 we can actually get our hands on and run on our own hardware. Now, for any fair fight, you need a proper arena, right? So let's take a quick look at the hardware we'll be using to push these models to their absolute limits. Our testing ground is an Apple M2 Max with 32 gigs of RAM. But here's the secret sauce, the really crucial part. By default, the system holds back a ton of memory. So I had to run a special command to unlock more VRAM, pushing it all the way up to 27 gigabytes. Honestly, without this little tune-up, we wouldn't even be able to load these massive models in the first place. All right, first up to the plate, it's our 27 billion parameter challenger. We're calling this one the brute force brawler, and you're about to see exactly why. So what does dense actually mean? Well, it means that to generate even a single word, it has to fire up all 27 billion of its parameters. It's like mobilizing an entire army for every tiny task. Sure, it's incredibly powerful, but it requires a just massive amount of GPU horsepower to pull it off. To really push its limits, I didn't just ask it to write a simple script. I gave it a genuinely complex task: create a command line program using PHP, a bit of a curveball from the usual Python, that could connect to a local service and turn a static image into a video. This is designed to test not just its coding chops, but its actual logical reasoning. And the results? Well, they were a real mixed bag. On the one hand, the code it produced was stunning, genuinely some of the most accurate I've seen from a local model. But the speed? Oh man, the speed was a huge problem. With a small 4K context, think of that as the model's short-term memory, it was already sluggish. But when we cranked that up to 128K, the performance didn't just dip, it completely fell off a cliff. Just look at this number for a second. 88.6 seconds. That's almost a minute and a half of just waiting for it to start generating a response. For any kind of interactive work like coding, that kind of delay makes it pretty much unusable. So here's the verdict for round 1. The output quality is fantastic, no question about it. But that dense architecture is just too demanding. It's completely GPU-bound, which is a fancy way of saying that unless you have an incredibly powerful and expensive graphics card, the experience is just not practical for most of us. Okay, so let's bring in our second contender, the 35 billion parameter mixture of experts, or MoE model. We're calling this one the Agile Specialist, and you're about to see exactly why. Now, this is where things get really, really interesting. Unlike the dense model, an MoA model works smarter, not harder. It has 35 billion total parameters, but for any given task, it only activates a small, specialized group of them, just 3 billion in this case. Think of it like having a huge team of experts, but only calling on the specific 1 or 2 you actually need for the job. The efficiency is just off the charts. And just look at these numbers. I mean, the difference is night and day. At 65K context, we're getting our first word in just 1.4 seconds. Remember the 88 seconds from the dense model? And even when we push the context all the way up to 250,000 tokens, the performance stays incredibly fast and totally stable. So for the ultimate stress test, I pushed it to its absolute maximum, 256K context. My computer actually threw up a warning, saying it needed nearly 32 gigabytes of memory. But here's the incredible part. Even with all that pressure, while I was screen recording with a dozen browser tabs open, it didn't crash. It just kept on working. It was amazing. All right, so after 2 intense rounds of testing, it is time to compare these results side by side and declare the winner of our local AI showdown. But before we crown the winner, check this out. This is a claim from Alibaba themselves. They're saying this new, efficient 35 billion parameter model is actually better than their massive 235 billion parameter model from just 7 months ago. It's a perfect example of just how ridiculously fast this technology is improving. When you put the numbers head-to-head at the 128K context mark, the story just tells itself. The dense model took a painful 88.6 seconds to even get started, while the MOE model was ready to go in just over 13. And the generation speed? It's not even a contest. The difference is absolutely staggering. And if you're a visual person, this chart says everything you need to know. The MOE model isn't just a little bit faster. It's nearly 3 times faster when it's generating text at this large context size. This isn't even a close race. So why is there such a massive difference? Well, it all comes down to this. The dense model is GPU bound. Its performance is limited by your graphics card, a rare and expensive resource. The MOE model, on the other hand, is RAM bound. Its performance is limited by your system memory. And since most of us have a lot more RAM than we have elite-level GPU power, the MOE architecture is just way more practical and accessible for everybody. And so, that brings us to our final verdict. For anyone looking to run powerful AI locally on hardware that people actually own, the Qwen 3.5 35B mixture of experts model is the clear, undisputed champion. The balance of intelligence, speed, and efficiency is just incredible. And because this model relies so much on system RAM, it could be an absolute game changer for Windows users who often have tons of memory to spare. Which brings me to our final question for you. Should we put this champion to the test on a Windows PC next? Let us know what you think in the comments. Thanks for watching.